Welcome to our presentation on a proof-of-concept application, showcasing the potential of converting natural language and voice input into SQL queries for seamless interaction with databases. This is built on OpenAI's state-of-the-art models, combining the work by Salmon and ChatGPT in the development process. Interestingly, ChatGPT has played a significant role in the actual coding, demonstrating the power of AI-driven development. We would like to highlight a few key points about our collaboration and the technologies behind this proof of concept. First, as mentioned earlier, the development has been carried out together with ChatGPT, showcasing the capabilities of AI-driven programming. The voice you hear during this presentation is also generated by an AI model created using Elevenlabs Voice Studio. Unfortunately, no good Swedish voice was available at the moment. Some important aspects of this proof of concept includes the use of OpenAI's advanced language models for natural language understanding and processing, the integration of natural language and voice recognition technologies, which is transforming the way we interact with data. The potential to increase database accessibility for a wider range of users, making it more inclusive and user-friendly. The application leverages OpenAI's API to facilitate seamless communication between the AI model and the user.
On this slide, we will discuss the key features of the proof-of-concept application, which focus on enhancing the accessibility and usability of databases for a diverse range of users. Natural language to SQL. The application enables faster and smoother database access by converting natural language queries into SQL. This not only simplifies the process but also reduces the time spent on crafting complex SQL queries. Natural language to SQL makes databases accessible for non-technical users by allowing them to interact with the database using natural language. This opens up the possibility for users from different backgrounds to access and analyze data with ease. Voice to SQL. Another significant feature is the voice input option, which allows users to speak their queries instead of typing them. This further simplifies the process and makes it more inclusive for users with different abilities.
On this slide, we will provide a brief overview of the technical aspects of the application. The application utilizes Python and PyQt5 to create a user-friendly graphical user interface, GUI, that makes it easy for users to interact with the database. Natural language processing. OpenAI's GPT-3 is used to convert natural language queries into SQL queries. This advanced language model enables the application to understand and process user input effectively. Voice recognition. The speech-recognition library is employed to convert voice input into text, providing an alternative method of input for users who prefer speaking their queries. Database connection. The application uses a standard ODBC connection string to connect to SQL Server, allowing for seamless integration with various database systems.
The diagram that is shown was produced by asking ChatGPT to draw a diagram based on the Python code. The user interacts with the application by inputting a natural language query or speaking a question. The GUI, graphical user interface, receives the user's input and sends it to OpenAI's GPT-3 model for processing. GPT-3 processes the natural language query and converts it into a SQL query, which is then passed to PyODBC, a Python library for connecting to databases. PyODBC executes the SQL query and retrieves the relevant data from the database. The GUI displays the results of the query to the user, completing the cycle and allowing for further interaction. If the user chooses to use voice input, their speech is captured and processed by the speech-recognition library, which converts the spoken words into text. The resulting text is then sent to the GUI, where it is treated as a natural language query and follows the same workflow as described above.
In this slide, we present an image of the application's interface, highlighting its main features and functionality. The main window is designed with user-friendliness in mind, offering an intuitive layout that facilitates user interaction. At the top of the window, there is an input field where the user can type in their natural language query. Alternatively, the user can choose to ask their question using voice input by clicking the designated button. The application incorporates a voice input feature, which records the user's speech and converts it to text using the speech_recognition library. This allows for a more accessible and convenient mode of interaction with the application. Based on the user's input, whether typed or spoken, the application generates and executes the corresponding SQL query. The results are then displayed in a table format within the main window. This interface is designed by ChatGPT. The instruction to the model was VAR-Creative.
In this slide, we'll demonstrate how the application works in real time by showcasing a practical example. The user will input a query in Swedish. Vilka är de totala försäljningsintäkterna för varje kategori, which translates to, what are the total sales revenues for each category? Upon receiving the input, the application leverages OpenAI's GPT-3 to translate the natural language query into a valid SQL statement. After executing the SQL query, the application displays the results in a user-friendly table format. The user can quickly and easily see the total sales revenues for each product category, showcasing the power and efficiency of the application in simplifying database interaction using natural language.
In this slide, we'll demonstrate another example highlighting the application's voice input feature. The user will use a microphone to ask the query, "Show all orders for the product and category." The voice recognition system may not capture all words perfectly. In this case, it recognizes "on" instead of "all." Despite this minor discrepancy, the application, with the help of OpenAI's GPT-3, still manages to understand the intent behind the query and translates it into an accurate SQL statement. Once the SQL query is executed, the application presents the results in an easy-to-understand format, showcasing its ability to effectively handle voice input and provide users with a seamless experience when interacting with databases using natural language.